All right, here's my second video where we're talking about the graphs of sine and cosine. In this example, I'm going to deal with cosine instead of sine like I did on my first video. This one will likely go a little bit faster than my first video. This one was kind of an introduction. This one I'll assume you already know everything from the first video. So what's changing here is instead of having transformations of the sine graph, I'm going to have transformations of the cosine graph. So instead of starting out in blue with the sine graph, where again my angle is on the x-axis here, which I recognize that's a little bit confusing because we've been using the letter t to represent the angle, but now we're thinking inputs and outputs. The input's the angle, the output is cosine. Cosine is the x-coordinate on your unit circle. So when t equals 0 at this point right here, the cosine, the x-coordinate, is 1. What I'm saying is when I graph cosine down here, when the input is 0, the output should be 1. And similarly, when the input is pi over 2, the output should be 0. Right, you can verify that up here. Pi over 2 is talking about this point. The x-coordinate here is 0. And then negative 1. And then 0. And then positive 1 for the x-coordinates as I go around in a circle. So what's going to happen is my dots are going to show up here, 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 and here. And just like I did in the other video, I can kind of measure these angles backwards. Measure them clockwise instead of counterclockwise. And get this. And now I want to try my best to connect these dots, and it's probably going to be a mess like it was in the last video, but I'm going to try my best to get the general shape of this guy. It's this nice curve that looks more or less. I'm doing a little bit better than I did on the last one, not to brag. Like that. Good enough. And it goes on forever in this direction, and it goes on forever in this direction. And again, there's the animation if you really want to see it. Here's the angle here. Here's where the angle is 0. Note the height is 1. And the height goes down, bottoms out, comes back up, and it does that forever and ever and ever. It loops, kind of like sine does. Now I'm talking about this blue graph here. Anyways, what I want to talk about is amplitude, midline, period, and phase shift. In the last video, we said that the amplitude is always just the absolute value of A. If I think about this as, let's see, let me switch colors here. Let's be consistent. We'll make the transformations in red again. This is A cosine of bx plus c. And again, some books use a minus there. I think it's easier to use a plus. The amplitude used to just be the absolute value of A. It still is. It's awesome. So in this case, A is negative 2. My amplitude is exactly 2. The midline used to be whatever D is. It still is. So D is negative 1. And I can use these two facts to kind of put my vertical bounds in here. My midline is at negative 1, which is what it was last time too, right? Yeah. So that means kind of the middle of my graph will be here. You don't have to draw these dotted lines, just for reference. And then since the amplitude is 2, it's going to get 2 above that point and 2 below that point. So it's going to get as high as this dotted line and as low as this dotted line. That might be a useful guide for drawing this thing later. So I got all the vertical stuff taken care of. Now I got to worry about the horizontal stuff. Period. Remember above here, it was 2 pi over b, although really you don't want it to be negative, so we say 2 pi over the absolute value of b. Same thing here. 2 pi over the absolute value of b. B in this case is 1/2, so I have 2 pi divided by 1/2. Fractions divided by fractions, that's the same as 2 pi times 2. That's 4 pi. So what that means is it's going to take 4 pi before this thing repeats. I think I'm going to extend my graph a little bit so that you'll be able to see that repetition, even if it gets a little bit ugly. So there's pi, 2 pi, maybe this is 3 pi here, and this is 4 pi out here, and 5 pi, whatever. All right. So the period is 4 pi. The phase shift, just like it was before, it's always negative c over b. As long as you're defining B and C as I do here, because I think that's the easiest. With all due respect to some publisher who thinks differently. So negative C, C is negative pi over 2. So the negative of negative pi over 2 is positive pi over 2. But I want to divide that by B, which is 1/2. And again, if you write this as multiplication by multiplying by the reciprocal of the denominator, if that means anything to you, you'll figure out that that's pi. What I'm saying is my starting spot, which used to be right here, is now going to have an x-coordinate of pi. So left and right, it's going to be over here at pi. Right? Up here, my starting spot had an x-coordinate of negative pi over 2. That was this dot right here. Down here, my x-coordinate has a starting spot of pi. Got to be a little bit careful. A big difference between cosine and sine. The cosine graph starts out up at the top if you want. So it starts out up here. The sine graph starts out in the middle. So when my x-coordinate was negative pi over 2, this dot went in the middle. Down here with cosine, because I start up at the top here, when I have a phase shift at pi, you're probably thinking that I should start right here. And normally I would, except for this negative here. Remember that before we started drawing here, we had to figure out our orientation. Should we start out by going up, or should we start out going down and have a graph that kind of looks more like this? Well, normally you start out going up, but if you have a negative out in front here, it reverses the orientation and you go in the other direction. Fortunately, that didn't happen up here. Down here it does happen. This negative is going to flip everything vertically. So I'm still within these bounds that I have, but instead of starting out at the top, I'm going to start out down at the bottom. So what that means is my starting spot, and again I use that term like with air quotations, should have an x-coordinate of pi, I'm talking about right here, and its y-coordinate should be all the way at the bottom. This right here should be my starting spot. And then what I want to do is I want to draw something that has a period of 4 pi. So maybe I should have gone one more out here. Here's 5 pi. I want this to do one entire revolution when it gets from pi all the way out here to 5 pi. And in this direction, 3 pi. Right? Because pi minus 4 pi gets me to negative 3 pi. So when I draw this graph, up here, I had a period of just pi. It did one full revolution, which with the sine graph is up, down, up, right? Up, down, up. Did one full revolution every pi for its x-coordinate. Down here, I want to do one full revolution, which for the cosine graph, a full revolution, it just goes down and then back up, unless I reverse the orientation, in which case it's going to go up and then back down. I want to do that every 4 pi. So what I'm saying is I want to start out here and go up and back down by the time I get to here. So halfway in between here and here, halfway in between here and here, halfway between the two maximums is a minimum. Halfway between these two minimums should be a maximum. What I'm saying is when the x-coordinate is 3 pi, my height should be as high as it ever gets right here. And you can put other points in between there if you want. Halfway between a maximum and a minimum, I'm on the midline. So halfway between this minimum and this maximum, I should also be on the midline. It should go through this point right here. And halfway between this max and this min, I should be on the midline. So we're talking about right here. Let's see, here's two minimums. Halfway in between the two of them, there should be a maximum. Halfway in between this minimum and this maximum, I should be on my midline. Halfway in between this minimum and this maximum, I should be on my midline. So I guess that's right here. And then try your best to connect these with the same general shape that we've had. That would look something, loosely speaking, like this. Sorry, I'll go quickly. Silence is deafening. Good enough. Remember, this continues on either forever in both directions, but this is more than enough to show the picture of what's going on. When I test you on this, I'm going to give you this. I'm going to ask you A, B, C, D, and then E will be sketch a graph. So there's an example with cosine. I'm going to have one more video where we kind of do the same thing, except we head backwards. You start out with the graph and you answer all these questions and eventually come up with this. But I'll save that for the next video, so that's the end of this one.